Hello everyone, welcome to Encryption, the tech tips and tutorial channel. In this video of AWS tutorial series, I will know how to create a new default VPC or the virtual private cloud in Amazon Web Services or AWS. Let me give you an overview of the video lesson in brief. We will create a default VPC or the virtual private cloud, which is a virtual data center in the AWS cloud. The VPC houses all the resources of an organization, including the networking devices, hosts, nodes, subnets, services, and so on. Then we will create an internet gateway, which is a virtual router that takes care of the incoming and outgoing traffic to or from the public network. Next, we will create two subnets, the public subnet and the private subnet. Resources on the public subnet will be accessible from the internet, but not the instances on the private subnet. The instances on the private subnet can, however, connect and communicate in the internal network. The subnet address of the public subnet will be 172.31.0.0/20. So the resources in the subnet will get IPv4 address from within the subnet range. This subnet is selected just randomly. However, you can choose the size of the subnet as per your network plan and as per your need. Likewise, the subnet address of the private subnet will be 172.31.100.0/24. We will also create or modify two route tables. One to route the traffic of public subnet to or from the subnet to the internet gateway, and the other is to route the traffic within the private subnet. Next, we will create or modify a security group which provides an instance level security. The security group will define what traffic to allow or restrict from which source to an instance. Finally, we will create or modify an NACL or the network access control list. NACL is a network level security. That means it defines what traffic to allow from what destination to which subnet or which network. So we will associate both the subnets to the network ACL. This completes the VPC creation process. Then we will create two EC2 instances of a Linux OS and configure them as per our diagram. Then we will access the Linux instances. So let's move towards the practical tasks. First of all, let's log into the AWS Management Console. And create a VPC. For this, click on the services and click on the VPC. Here, as you can see, there is no VPCs, no subnets, no route tables, and no any other services running on my AWS cloud account. That's because I have cleared out everything for this demo. Next, click on the VPCs. Click on Actions and click on the Create Default VPC. Here too, click on the Create Default VPC button. As you can see, the default VPC with the given VPC ID is created successfully. Here, clicking on your VPCs, we can see the VPC that is listed under your VPCs section. Next, we will create all the stuffs and modify the existing ones as per our cloud architecture diagram. Now the VPC name is empty or just the dash symbol. Let's rename it. Hovering over the dash symbol, we see an edit icon. Click on it. You can get a box here. Type the name of the VPC, for example, my-learning-VPC. Then click on the save button or just hit enter. Next, let's create an internet gateway. One internet gateway might already have created by default while creating the default VPC. Let's rename that too. I'm going to edit the name of the default internet gateway as my-learning-IZW. Since it's already attached to the default VPC, we don't need to do anything more here. So let's move ahead and create subnets. As per our cloud architecture diagram, we'll have two subnets. One is for publicly accessible resources and the other is for internal resources. But here we can see several subnets that were created by default while creating the default VPC. The default VPC creation process creates several subnets as well in the different availability zones. This is for high availability. That means if one subnet is down due to any reason, others are going to tolerate the fault of that subnet. Scrolling towards the right, we can see that they are created on the different availability zones. For this demo, we don't need more than 2 subnets, so I'm going to keep one and delete all the others. Although we need 2 subnets, I'm going to keep only one, and I will show you creating a new subnet. Okay, the selected subnets are deleted successfully. Let's rename this subnet as public subnet. We will associate this subnet to the internet gateway so that the resources having the IP address of this subnet will be accessible publicly, that is from the internet. Now let's create a new subnet. Select the VPC, give a name to the subnet, for example, private subnet. Let's leave the availability zone as no preference, and let's assign the subnet CIDR block as 172.31.100.0/24 and click on the Create Subnet button. The new subnet is successfully created, and here if we clear out the filter, we can see both the subnets. Moving on to the next steps, let's create route tables. We need to have 2 route tables as per our cloud architecture diagram, the public RT or the public route table and the private RT or the private route table. The one is already created while creating the VPC. Let's rename it as public RT. Then let's create a new route table. Give a name to the route table. In our case, it will be private RT. Then select the VPC. We have only one VPC, the default VPC. And finally click on the Create Route Table button. Okay, the route table is successfully created. Clicking on the route tables here, we can see them. Next, select the public RT. Go to the Routes tab and click on the Edit Routes button. Here we had to specify the internet gateway destination as the 0.0.0.0/0, which means allowing the traffic from the internet to the internet gateway as specified on the target box. This is just like our edge router that is facing towards the internet or our main router. Since the values for the destination and the target have already been filled in correctly, we don't need to do anything here. Next, we need to associate the subnets to the route tables. So again, click on Public RT, go to the Subnet Associations tab, select the public subnet and click on the Save Associations button. In the same way, let's associate the private RT to the private subnet. As the next step, let's configure security groups. As we have discussed earlier, security group provides an instance level security. That means if we want to allow or disallow anything on a particular host or particular resource in the AWS cloud, we need to configure a security group with the required rules and then attach the security group to the instance or the host or any other resource. Here we already have a security group created by default, that is at the time of creating the VPC. Let's rename it first. I'm going to give the name as my-learning-sg and then click on the Save button. Then let's create inbound rules. Click on the Edit Inbound Rules. Here we can see that one rule is already there that allows all the traffic to this security group from this security group itself. It is like a rule that restricts everything on the host with this security group. So let's add a rule so that the SSH connection is allowed only from my IP. Also, I'm going to add another rule that allows the HTTP traffic from all IPv4 addresses. That means if I configure the EC2 instance as a web server, it's going to listen on the HTTP port and allow all the HTTP traffic on the EC2 instance. That's all we need to configure on the security group for now. So let's move ahead and configure the NACL or the network access control list. This is a network level security. If we want to configure security to an entire subnet, then we can configure an ACL. First, let's rename the default network ACL that was created when creating the VPC. Then let's edit the existing inbound rules. Here too, we need to allow all the traffic or some required protocols traffic from our IP only, so that others from the outside network do not get access to the subnet. Finally, save the changes, and we are now all done with the process of creating the VPC. Now we will create the EC2 instances as per our cloud architecture diagram and access them using a Linux shell. But that doesn't mean that we will install a Linux operating system or we will use a separate PC to access the EC2 instances. Instead, we will install a tool in our Windows operating system which provides the Linux shell. First, let's create an EC2 instance that will be accessible from the internet. Click on the services, click on the EC2. Click on instances. Let's clear the filter, and here we don't have any EC2 instance on any status, running, stopped or terminated. If you already have an instance on any of the statuses, you can just ignore it for now and launch a new instance. Here I click on the AWS Marketplace and search for the CentOS Linux for this demo and hit enter. You can choose any operating system, however. We should select the free tier eligible one, otherwise we'll be charged with some dollars. Click on continue. The type is t2.micro, which is a free tier. We are okay with this. So let's move on to the next, configure instance details. Here everything is okay for now. But we need to check on which network or the VPC we are going to attach the EC2 instance. In our case, it's the default VPC. Likewise, we should also take care about the subnet on which we are including the EC2 instance. Since we want to access this EC2 instance from the public network, we should select the public subnet. And let's enable the auto assign public IP option so that the instance is assigned with a public IP address by which it will be accessible to the public network. Other configurations do not look to require modifications. So let's move on to the next add storage section. For now, we don't need to modify anything here as well. So let's move on to the next, add tags. Let's add a tag to the EC2 instance so that we can search for the instance or filter it in case we have several instances. Enter the key as name and the key value as anything you want to. For example, I name it as public-ec2-CentOS and then move on to the next, configure security group. By default, create a new security group option is selected, but we are not going to create a new security group now because we have already created a security group while creating the VPC. So we can just select an existing security group. Check on the security group ID and click on the review and launch button. Then click on the launch button. The final step of creating an EC2 instance is creating a key pair file. This key will be required to log in to the EC2 instance remotely. Since we don't already have a key, we are going to create a new key pair file. Then give a name to the key pair. Download and store in a safe and secure location of your computer, because using the key pair, anyone can log into the EC2 instance. And then click on the launch instances button. It may take some time to create an instance, so I fast forward the video. Then scrolling down a bit, click on the View Instances button, which takes you to the Instances section. The EC2 instance is created now, but it's on the pending state. It may take quite a bit of time. Meanwhile, let's download a tool that provides a Linux shell to access the EC2 instance. In the New tab, search for Git Bash. Now click on the Downloads-Git link. Click on Windows and click on 64-bit Git for Windows setup link. Store the installer in a location of your computer and wait for some time until the download is complete. After the download is complete, click on it to begin the installation. As usual with installing a Windows installer, for Git 2, click on a couple of next buttons and click on the install button. Now before you click on the finish button, uncheck the view readme box and now click on the finish button. Also, I'm not going to check on the launch Git bash because we will launch it manually. Now let's launch the Git bash. The one way for this is to click on the Windows icon on the bottom left corner or press the Windows key on your keyboard that opens the Start menu. Most of the times you find it listed here on the recently added section. If you don't, type the keyword git space bash on the search box and click on it. This is the Linux shell on which we can run any valid Linux command on Windows. Next, we need to switch the current working directory to the directory where our AWS key pair file is stored. We can use the cd command to change the current working directory and give the directory path such as g:. If you run the pwd command, you will see your current working directory, that is for now G drive in my case. Then I change the directory to aws/aws-creds where the key pair file is stored. We can check or verify the directory path using the Windows UI as well. I'm going to delete the last 3 key pairs file here, which I downloaded while creating other resources in the AWS previously. Going to the Git bash and typing the ls command, we can see the key file in the .pem extension. We will use this key to log into the AWS EC2 instance remotely, that is from our computer. To get the login information, let's go to the Instances section in the AWS Management Console. Now we can see the instance is on the running state. Select the instance, click on the Connect button, and here on the SSH Client tab, we get information about how we get access to the EC2 instance via the SSH. On the step number 3, we can see that we will need to change the permission of the key pair file so that it will not be publicly viewable using the given command. So let's copy the command. Then go to the Git bash and paste the command. Then copy the commands as shown in the example and paste on the Git bash. If you are asked yes or no question here, type yes and hit enter. Here we go. We are now logged into the EC2 instance remotely via the SSH. To check which operating system is it, you can run cat /etc/os-release command. Here you can see it's CentOS 7. Now let's create another EC2 instance of the same type and the same configuration but in the different subnet. That means we will put the EC2 instance on the private subnet and check if we can log in to the EC2 instance from our computer remotely via the SSH and using the public network. All the steps to create the EC2 instance will remain the same except the subnet selection and the tag name. Also, we will use the same key pair to access the EC2 instance. Okay, the other EC2 instance is now created and it's on a pending state. Let's wait for some time. After the current state of the newly created EC2 instance turns to running, copy the login command as given on the example, go to the git bash and paste the command. Even waiting for some time, we see it's not responding. Let's verify the status of the instance. We are confirmed that it's running. And here on the git bash, we can see connection on the port number 22 is timed out. Let's run the command once again. This time too, we got connection timed out. Let's also ping the IP. We get all the requests timed out. This is because the EC2 instance is placed under the private subnet, which is not accessible from the internet. That means only the internal hosts or resources within the same subnet will get access to the EC2 instance in the private subnet. This is what we exactly expected to get on this video tutorial. With that, we have now come to the end of this video. I hope the video was useful to you. Please subscribe our channel and hit the bell icon to get notified as the new videos are uploaded. Thanks for watching. See you on other videos. Till then, have a nice time. Goodbye.